Let's do one more example like this one to show you how a reflection on the y-axis going to happen. Okay, so we are going to keep everything as is, but we're just going to change this now to the y-axis. Remember, the y-axis is the vertical axis. Okay, so if you're going across the y-axis, y must not change, yes? So we expect the 9 to remain the same, but we expect the 3 to become a -3. Agreed? So let's just see what it says. That's the final answer, but let's take a look at the steps. Reflection. Reflect the point. First, we reflect the point 3,9 across the y-axis. The rule for this reflection maps xy to what? -xy. So the x have to change sign, but the y remains the same. So for the point 3,9, as we expected, x reflection becomes -x. So the 3 becomes a -3 on the other side of the y-axis, yes? And the y remains the same. So the reflected point is -3,9. Okay, the reflected point -3,9, the transformation can be represented as 3,9. Reflection in the y-axis becomes -3,9. So the translation, we all know what to expect. We're going to add the x to -3 and add the y to 9, isn't that so? So what is our vector? Our vector is 4,6, isn't that so? So 4 is x, or x is 4, and 6 is y, yes? So what is going to happen? We have to add 4 to -3. So -3 plus 4 becomes 1. And we have to add 6 to 9. So 6 plus 9 becomes 15. Okay? So the final point after the translation is 1, 50. And always remember, when you're looking at videos, always pause and participate in the video. Here we're going to try another video on another presentation, but y is equal to a number other than 0. Remember, y is equal to 0 is the x-axis. Let's say y is equal to 5. Okay? And let's keep everything else the same. So remember, y is equal to 5 is a horizontal line, but it's above the x-axis. Okay? So let's see the reflection. The final answer is 7,7. First, we reflect the point 3,9 across the line y is equal to 5. The rule for the reflection across the horizontal line y is equal to k. Y is equal to k is a horizontal line, maps the point x, y to x, 2k minus y. So you have to learn that rule. It is 2k minus y. The x remains the same, but the new y coordinate will be 2k minus y. So you multiply 2 by k, whatever k is. Here k is 5, right? And then you minus the y, which is 9. X remains the same. So as it says, the point 3,9 and the line y is equal to 5. X reflection. So the 3 will remain the same, but the new y now reflection will be 2 times 5 minus 9. Okay? Because k is 5 and y is 9. So you're going to get 1. So the new point is 3, 1. The transformation can be represented as 3,9 reflection in on y is equal to 5 will be 3,1. And the translation, you simply add the vectors to the accordingly. The x have to multiply plus the x. That's 4 plus 3 will give us 7. And 6 plus 1 will give us 7 also. So let's try another one where you have x is equal to a number. Let's say x is equal to the same 5, for example. So x is equal to 5 now is a vertical line. Okay, bear that in mind. So the y will remain the same, but the x now have to change. How will it change? Let us see. The final answer is 11,50. Let's see how this was obtained. So first we reflect the point 3,9 across the line x is equal to 5. The rule for reflection across the vertical line x is equal to k maps the point x comma y to k minus x. Okay, you can see the similarities, right? The y will remain the same, but the new x is going to be 2k minus x, yes? So for the point 3,9, the line x is equal to 5. The x reflection will be 2 times 5 minus 3, which is 10 minus 3, which is 7. And the y remains the same. Okay? So the reflected point 7,9, the transformation can be represented as 3,9 reflection. X is equal to 5 will be 7,9. The 9 remains the same, but the new x will be 7. That will be 2 times 5 minus 3, isn't that so? And the translation, the rule always remains the same. You just add the x to the x's and the y's to the y's. So the 4 will be added to the 7 to give us 11. And the 6 will be added to the 9 to give us 15.